Hey everyone, so this is going to be question number 2, and it's like a what would Python do on mutability. This is for discussion number 5. And so yeah, I'm going to go into the answers right here. And so I'm running this through like Python tutor, not the interpreter, but it's kind of the same thing, but yeah, so at the beginning I'm going to start off with like this little list right here, just because Python tutor won't really save all the answers for you, so I'm just going to like get a list, like record all of them. And you see there's like a bunch of pens right there. But yeah, let's get started. And so starting out, we started with like S1 is this list with the elements 1 to 3, and then S2 is S1. And so remember that lists are objects, and you're going to store these pointers when you like refer variables to each other. So S1 is pointing to this list 1 to 3, and we say that S2 is S1, and what we're going to do, they're going to end up pointing to the exact same thing because they're objects. And then if we say S1 is S2, remember that the is operator checks for like identity to like make sure they're the exact same objects. So in this case, S1 and S2 are pointing to the exact same thing. So it's gonna the answer is gonna be true right here for S1 is S2. Yeah. Now we say S2 dot extend of the list 5, 6. So we're adding the list 5, 6 to like what we currently have. So the elements 5 and 6 are gonna get added on, and then we're going to see what S1 indexed at 4 is. And in at index 4, we see that it's 6. And so that answer right there is going to be 6. And then now we have s1.append -1, 0, 1. And unlike extend, which adds like the elements of a list that you pass in, append is going to add the entire thing as a single element. So we're going to take what S1 is, it's this list right here. We're going to add a single element, and that single element is the list -1, 0, 1. And then so yeah, we got a little pointer coming out from index 5. The pointer is going to the list -1, 0, 1, which you just added. And then we're trying to find out what S2 indexed at 5 is. And what's S2 indexed at 5? Well, remember that S2 is S1 right now. They're pointing to the exact same thing. So S2 indexed at 5 would be the list -1, 0, 1. And so yeah, that would be our answer. 2 is pointing to the list -1, 0, 1 right there. Yeah, and then what happens after? S3 equals S2 spliced. And so remember that splicing, what happens is that we create a copy of the list. But remember that it's a shallow copy and not a deep copy. So imagine if we have a nested list. And so in this case, we have a nested list right here. Like the negative list -1, 0, 1 is inside of like the bigger list. And so what's going to happen here is that we create a shallow copy. So as you can see right here, we like copied over the elements 1, 2, 3, 4, 5, 6. I mean 1, 2, 3, 5, 6. Those are primitive objects, so they don't have any like sort of pointers and all of that. But in the case of like the list right here, we don't copy the entire list. We just take the pointer, whatever index 5 was pointing to, we put that's like the new pointer for index 5 of the new list. So we don't copy the list over, we only copy pointers, and if they're a primitive object, we copy them over. But yeah, and then afterwards, we go like, sorry, s3.insert at index 3, and then s2.pop a 3. And so this line is a bit more involved, so let's go through it like step at a time. And so let's ignore the insert part, and let's evaluate the operands first. And so 3 is 3, but then s2 pop at index 3. And so what pop does is it like basically removes whatever element is at index 3 of whatever list that is, which is s2, and it's going to return it. So we go to S2 right here. We see that at index 3, we have the number 5. So what's going to happen is that we're going to remove the number 5, and we're going to add it, and it's going to get returned by pop. And then we're going to add it at the third index of S3. So at the third index of S3, we should be inserting a 5 right here. And then if you might imagine, you like make space for that element right there. And then the 5 at index 3 in S2 and S1, that gets removed. And so if you go past this line, you can see that the 5 got removed right there. Everything got shifted left a little bit. And then inside of S3, the 5 got inserted at index 3. And then now we want to check what length of S1 is. And as we see right here, it's length 5. 1, 2, 3, 4, 5. Yeah. And then now we want to check, is S1 indexed at 4? Is it S3 indexed at 6? So S1 indexed at 4, what is 4 pointing to? It's pointing to the list -1, 0, 1. And then S3 indexed at 6, what's it pointing to? It's also pointing to the same list. So they're the exact same thing, so we're going to return true right there. Or we're going to append true to our answers or something. But yeah. And then next, we have S3 indexed at this like little convoluted thing inside. So let's find out what the thing inside of this is. And so S2 indexed at 4, what is that? That's going to be the list -1, 0, 1. And then indexed at 1. At index 1, it's going to be the number 0. So the inside of this S3 indexed at something, that something is going to be 0. This entire thing right here. And S3 indexed at 0, that's going to be 1. And yeah, we get 1 out of it. And so like indexed at 0, S3 indexed at 0 is 1. Yeah. And then next we have S1 spliced at 3 to the left is S2 spliced at 3 to the left. And so thing to note about splicing is that it creates shallow copies. And so what happens here is that, S1 indexed at 3 to the left is all of this. S3 from there on is also 1, 2, 3. They're the same thing, but they're not the exact same thing because splicing makes copies, and even so, these are not coming from the same list in the first place. And so they have the same elements, but they're not the exact same object. So you can imagine S1 spliced at 3 to the left is going to be pointing to a different list than S2 spliced at 3 to the left. Although they have the same elements, they're not the exact same list. And so because of that, we're going to append false. The answer is going to be false. But yeah, and then next we have S1 indexed at 3 to the left is equal to S2 indexed at 3 to the left. And then the equals operators is going to check for equality. And so as we just discussed, is checks for like identity. Are they the exact same thing? And S1 indexed at 3 to the left has like the same elements as S2 indexed at 3 to the left, but it's not the exact same thing. But in the case of line 23, the one we're on right now, it only checks if the elements are equal to each other. And in this case, they are, because it's like both are 1, 2, 3. And so we're going to append true. And then last but not least, we have answers that append. Ignore the append stuff. But S3 indexed at 6, indexed at 3. And then so if we go right here, S3 indexed at 6, that's the list, -1, 0, 1. And then indexed at 3, did I mess up? But this looks like an error. Yeah, it looks like an error. Let me check if it is supposed to be an error. Oh, did I miss this line right here? Okay, let me add this real quick. Yeah, I missed something. Yeah. So we're supposed to take S1 indexed at 4 and append 2 to it. And so we look right here and we see like, what is S1? And S1 is this index 4. Is this list -1, 0, 1? And what do we want to do with it? We want to append 2 to it. So after running this line, we're going to have 2 added to the very end. And then what we do next is we go like S3 indexed at 6. And then remember that 6, the 6 right here, and 4, index 4 of S1/S2, they're pointing to the exact same list. And originally it didn't have an index 3, but we just added 2 to the end of it via S1. And since they're pointing to the same thing, we can now index into S3 indexed at 6, which is the list -1, 0, 1, 2, which you just added 2 to. And we can index into 3, and it's going to be 2. But yeah, it's going to be 2 right there. And yeah, this is going to be all of this what would Python do with mutability. And I might have messed up my explanations. So if you have any questions or any conceptual questions or really just anything, feel free to like email me. You know my email. But yeah, hope you have a great day.